everybody. This is the sixth lecture of the basic electronic course. I'm Dr. Saad Ahmad, and today we will be continuing our discussion about the diodes, and we will learn how they are used and different characteristics about them. In the last lecture we have seen this diagram. We have seen that at this junction what happened was that the electrons from this side, the n side, crosses the boundary and moves to the p side where they occupy the holes present in there, and in this process they form ions on both sides, and these ions are basically missing the charge carriers, and this area is missing basically the charge carriers, so they are going to behave as insulators. And we discussed that this area is then called the depletion region, and if this diode is made up of silicon material, then the depletion region has the potential difference of 0.7 volts, and if this is made of germanium, then the potential difference will be of 0.3 volts. Okay, next thing is to bias a diode. And why we have to bias a diode? Because whenever we want to use this any semiconductor device, we have to provide external DC voltages to it so that it can be used. So biasing a diode is the first thing, or biasing any device, electric semiconductor device, the first thing you do when you want to use that. And biasing is basically of two types: forward biasing and reverse biasing. Forward biasing and reverse biasing. As I said, the use of DC voltage to establish certain operating condition for an electronic device. Either of these bias conditions established by connecting a sufficient DC voltage of a proper polarity across the PN junction. So this is very important, that you have to know how to forward bias or reverse bias. Okay, let's see why when we forward bias a diode, what we do. Simple terms, we'll read it out, but simply try to understand. When positive terminal of the diode is connected to the positive terminal of the battery, and negative terminal of the diode is connected to the negative terminal of the battery, then it becomes forward bias. In this condition, the forward biasing condition, the current will flow through the diode. The current will flow through the diode. That means forward biasing will allow you to flow current through a device. This external bias voltage is designated as V bias. The resistor R, shown here, limits the current to a value that will not damage the diode. That means that it is for protection purpose, and the V bias must be greater than the potential difference. This voltage means, to get the forward bias, if this diode is of silicon, then that means that you have to have at least 0.7 volts of V bias to make it forward bias. If it is less than 0.7 volts for silicon diode, then it will not allow the current to flow, because depletion region will not collapse. In case of germanium diode, it was 0.3 for germanium, so 0.3 will be the V bias to forward bias a germanium diode, and 0.7 for the is okay. When you bias a diode, because live charges repel, the negative side of the diode pushes the free electron, which are majority carrier in the N region, towards the PN junction. This flow of free electrons is called electron current, and current will flow through the diode. Okay, we will continue from here. We can see the effect of this forward biasing, and the effect is that the depletion region which is present initially in the middle of the two regions collapses and the current start flowing through it. Okay, look at this diagram, the IV characteristics and characteristics. We can see here that if you apply 0 0.1, 0 0.2, 0 0.3 up to 0.6 volt, there is very little current flowing through the diode, and you can see that is a very minor current. But once it reaches 0.7 for silicon diode, maximum current start flowing through it. So this is also known as knee voltage, these 0.7 volts, and if it was germanium then it will be 0.3. Okay, during the reverse bias, what we do is we connect the negative side of the battery to the anode, the positive, and positive side of the battery to n-type, the cathode. In this way, what happens is that electrons cannot flow through the diode, and the result, there is no current flowing through the diode. Reverse bias is the conditional that essentially prevents current flowing through the diode. Why this happens? Because of this basic reason. The reason is that when you reverse bias a diode, it widens the depletion region. The area of the depletion region extends. The positive side of V bias is connected to the N, which attracts electrons. Similarly, the negative is connected to the P side, and the result is the depletion region is increased, which can increase to the maximum depending upon the breakdown voltage a diode can handle. For example, if I quote 1N4001 has a breakdown of 50 volts, so it can handle 50 volts in reverse direction, and there are diodes available which can go up to work up to 1000 volts in reverse direction. Okay, the characteristics, IV characteristics, you can see that in reverse bias there is no current, but once it reaches the breakdown voltage, heavy current flows through the diode and which destroys the diode. So if you draw the complete characteristic curve, on the positive side it is like this, that there's 0.7, and in negative side it is breakdown, which can be 50 and depending on the diode and its construction. Anyway, this is it for today, the characteristics of diode, and if you have any question you can contact me and ask. And I also want you to read the book which I have recommended for this course, because this is very important. Self-study is very important for you to have a good grasp of knowledge. Anyway, thank you very much. Allah Hafiz.